Good morning, everybody. Thanks for being here at this conference. I'm really excited to show you a little bit more from, let's say, the real world from power plants coming together with the robotics and the technology from APM. So let me quickly introduce a little bit more what I'm doing. I'm actually technical director from operation and maintenance business. So I wanted to tell you a little bit, what is that basically? Imagine the customer owns a power plant. He pays the fuel and sells the energy. And all the rest we are doing as GE Vernova on behalf of the client. So basically, we manage the whole power plant, the all assets, the daily operation and maintenance, and we provide, let's say, also the manpower there for the team which is on the site operating this power plant. So for a little bit to give you introduction to the business, we have like about 41 different sites where we operate about more than 100 gas turbines, but 44 steam turbines. And we have, let's say, more than 900 people on the different sites globally in 14 countries, which help us to keep the light on different countries and to different homes. And at the end of the day, they're doing their daily job. So really, what we do is basically, we are not only putting manpower there, we put, let's say, intelligence there and performance. Let's have a look on that one. So first of all, what is the different challenges we currently face in that business? So we having, let's say, on one hand side, we have like workforce challenges. We have like a workforce which quite have the getting to the retirement. So when we look at it, 2.4 old retired people getting out of the business and one new entrant we have. Then we have like people which have less than 10 years experience. Before 20, 30 years, we had like people which were all life working on a power plant in the same position. They already smell, feel when something is wrong on the power plant, and then they take the actions. And nowadays, we don't have these people. When the people are away, the know-how is gone. On the other hand, we have like industrial pressures. Let's say we see at the moment a big growth in data centers, really a big push there. So also a demand on energy. So all power plant needs to run longer. Normally a power plant has, let's say, 25 years of lifetime, and we extend that one in different regions. So we have like there some more challenges. We see also on the power plants that they, in certain countries where we have a lot of renewable, that the plant which were running before on base load were now running on cycling. This has an impact on the equipment, especially due to the changes on the temperatures. And what is also, before we had like quite a lot power in the grid, and right now we're looking into that one, that in certain areas we have really shortage on power and emergency will increase. So really a challenging business, and I think what I need is their support, basically how we can manage that one. So we really need data-driven inspection to get better on a better level. So what's driving my business, operation and maintenance more? And want to quickly only have a glimpse on that one. I mean, obviously, we are really driven by the customer to provide high availability, reliability of the power plant. as this one is one of our key factors because we provide also guarantees to the customer. But on the traditional way, when we look at, we need really key stuff on the power plant, which is knowledge. We need also what my team is doing. We provide the standards for our sites, that we get high availabilities. And we have also, let's say, the support from GE Vernova engineering, basically when we have like some issue on the power train, power island, GT generator, and steam turbine. But on the other side, what I really need more, and this is why I'm working with all this folk from APM, with the team here, is on one hand we have like on the powertrain we have monitoring and diagnostics, which helps us to detect something, but also asset performance management, and you have seen this one in different presentation and other presentation. What is important to get out of the data results. And here we bring this together. And what is also what we were starting with the already 2 and 3 years ago with ANYbotics to bring in robots to our sites to test and get value it. So we are now really on a better level. We have, let's say, these robots on the site because we see that this is really a high value for us and an improvement for us. So before we showed actually the robot with ANYbotics, I would like to give you an insight on the let's say some success stories which we have on our plants regarding robotics, APM, and let's say to working together with operation and maintenance. Okay, so we have like a power plant which I'm talking at the moment. It's in Ireland, and one of our key stories is there really to monitor the critical equipment. This is one of the important topics, and you get certain signals normally from a pump, what you have here, get to the DCS, and this is analyzed with APM. But what you get additionally with the robot is get some additional info. We see here that you have like some thermographic pictures, you have like some local readings, you can have like some level measurements, you have getting some sounds, and we see more details coming afterwards. But the important thing is with the robot we capture this data and we need to analyze it. And the big value is to bring the data together with the operation data from the DCS brings us the much better result. And here what we really do is with the critical equipment monitoring, we're doing clear analysis of the operation of the power plant at a different level, because not always at the power plant is running on baseload, nowadays even less. So we need to compare it at different stage of the operation of the power plant, then with the normal signals. And here with the critical equipment, we want really to do as well the maintenance when it's really necessary. So really not doing on a time-based schedule, we really want to do it when the equipment needs the maintenance. And here we really have like a solution which is helping us with the robot to get this data. So in the Ireland project, we have like the robot is going 3 days per day on his rounds. There are different missions, and he collects all the data and brings it in to our data lake. Now the second thing, what is really, and I think it's probably more interesting, which I would like to show is the success story, what we had just happened end of last year at the same place in Ireland. We had on the HRSG, we had a hotspot, and the robot actually detected this one end of last year. And you could not see anything from outside. And when you know normally operators doing every 3 months a thermography survey, then they will not find it, or when it's even too late. So with the robot on the daily mission, we could detect the hotspot on the boiler. And then what we did is basically we implemented with APM a monitoring scheme to actually monitor this one. We didn't want to shut down. We didn't see that as critical for a shutdown, but we needed to monitor this hotspot. And what we did then is basically we saw it over the last, in the first quarter, we had an increase from 10, 15 degrees over this hotspot. So the export, the damage was increasing. However, what we did, we contacted with our technical department, established, let's say, a reparation process, put it in improved solution there. What is basically, we have an improved solution for the insulation and the baffle plates inside in this area. So we got all this information, we could organize the whole material, we were able to actually prepare everything. And then just last month, during the scheduled outage, we had, let's say, prepared the scaffolding company, the different insulators, all the different team to actually go in, put the scaffolding, access it, repair it in time during the outage, and then close this issue. And it was really a success story, because when you would go in during the outage, see that one you could not repair, you would have, let's say, some extension of the outage, and it's really a benefit of it. And I think the important here is to show that we are comparing the data on monitoring, because that's the value what we can do. We can extend, we can assess, we get, let's say, every shift, we get the data about the hotspot, we can react, we can put the alarms on that specific asset, and then define the action. And here we really had the chance to actually extend the operation more than 3 months with this hotspot, monitoring always in place, with APM putting the right alarms over the different operation area. And thanks to this, we were able to actually get to that one. And I think it's really a great success to have that one. So really, I'm happy to go for the robot, and I think let's introduce what is important to have it on site. And because the robot doesn't speak yet, I have somebody who speaks for him. I would like to introduce Osama Darucci to show what the robot does.
Good morning, everyone. The star of the show. I'm just here to bring a voice to ANYmal, and of course, share a little bit of history, logic behind it. Again, we're at the moment, I think, in the history of robotics, of industrial robotics, mobile robotics, where we see this kind of technology becoming a reality in terms of value. I mean, you heard Adrian. And it's really an inflection point where after 15 more years of research and development, from the mid-2000s, where the research team at ANYbotics started working on ANYmal, now we're at an inflection point. We have the right technology, the right ecosystem, but most importantly, as you mentioned at the beginning, the right needs, right? We have in the energy market a lot of pressure on reliability, on availability, aging population, silver tsunami, everyone talks about it. I've been 5 years, I've been at ANYbotics, 5 years of hearing about silver tsunami. Now we see it becoming a challenge, right? But of course, all the HSE and inherent problems that we see in different plants. This is an inspection robot. I was last week with a utility company that has a fleet of 12, 14 plants. Since the beginning of the year, they already had 40 incidents, 2 of them with serious injuries. during their inspection rounds and routines. What that came from? They came from one of the best tools we have in our era, smartphones. People walking around with smartphone, tripping, and then injuring themselves, right? And that's not what you want, especially when you're missing workforce, where you have pressure to make sure that your plants are working the right way. So ANYbotics is a Swiss-American company. We have been founded in Zurich in 2016. The research team has been working on development of the underlying technology, legacy technology, since the mid-2000s. At the beginning, it was just about, hey, can we make computers walk? You know, engineers sometimes have funny ideas. They saw computers flying, computers on wheels. They're like, okay, let's make them walk. But then as you move towards the mid-2000s with the IoT and sensoring revolution, there were more and more requests, hey, can I maybe put sensors on a mobile platform to cover areas that are too expensive to put in wired sensors? Also in areas where maybe it is dangerous and expensive to reach. In 2018, we have had our first offshore deployment on a substation on the Northern Sea with a company called Tenet in Europe. So already early on, when technology was still a baby, we were already thinking industrial because it's in our DNA. We don't do military applications. We don't do entertainment applications. All what we do is pure industrial applications, and that's where $180 million in funding and a lot of brain power has been invested in the last almost decade. As you can see here, that's the lineage of ANYmal robots. Today, we're on the market with two of them. And the logic behind the robot is for you to get value out of it, and that's where we see the partnership with GE, is when you can combine advanced, industrial, ruggedized, reliable physical AI, the robot, with an advanced industrial AI, which is the competence, the domain expertise that we see GE has. And by combining the two, you can hopefully gather the data that you need for a better asset intelligence and ultimately actionable insights, because as Paul was mentioning yesterday, what matters is what can I do as an outcome of that data. The logic behind the robot is the following. You have a platform with sensors that can walk around and collect the data. To be able to do it in a good way, you need to be able to go everywhere. Outdoor, indoor, different weather conditions, stairs, difficult terrains, and that explains the legged robot setup. Otherwise, just use wheels. But you have seen, stairs are all over the place, you have not uneven terrains. If you go on a substation, you have grass, you have gravel, and so on. Then you collect the data, you run analytics, and of course you want that insight. So I will walk you through that process over the next less than 10 minutes. And that's exactly how ANYmal fits within the GE APM solution and ecosystem. ANYmal is one of the tools to collect additional data and insights, so to generate insights with the full solution. So the robot, we've been the first company with legged robots using reinforcement learning. We have been working on it for many, many years. The robot is completely water and dust protected, and we do also have an ATEX certified version that is coming out end of the year for explosion-proof application, oil and gas chemical. Extremely, extremely important for us. We already have a long list of orders, and we're the only company in the world to have it, because what matters to us, again, is industrial value. It's all about the value, the outcome. As I think Vipin said before, it's not about becoming, or look, a feature factory. Same for us. We don't want simply to make gimmick. We want to generate value. So the robot has to access the important areas, and in oil and gas chemical, those areas are X certified, and therefore our robot is X certified. The robot is using multiple sensors to work autonomously. So the autonomy is where we excel at. Our robot can work autonomously and collect the data from different areas. If you have to put, like for a drone, a human behind the robot, you are breaking the case, you're breaking the value of it. You can always go there and control the robot, send it up in different environments, but the real case comes when you have autonomy. Our ruggedized solution enables us to go into critical infrastructure, hazardous areas where the job of inspection is not fun, right? Oil and gas, power, utilities, chemical, minerals, metals, and paper. When you look at the industries we're covering, it's a very, very good fit with what GE Vernova is also covering with its solution. Once you have collected the data, we have multiple sensors, thermal cameras, visual cameras, directional microphones, acoustic cameras, gas sensors, toxic gases, hydrocarbons, and so on. You can start processing the data and detecting multiple anomalies from hotspot detection, but also, is your bearing having an issue? Do you identify a leak somewhere? Is there a steam trap somewhere? Is there a gas presence in an area where you don't want to have gas presence? And of course, you know, with AI nowadays, the list of use cases keep expanding on a quarterly basis. The value keeps growing and growing, despite the fact that the hardware stays the same. And then with the companies, we work on the strategy where it makes sense to start with robotics. You have different applications depending on the areas, depending on the sensor coverage, the asset criticalities. In the Whitegate case, we put the robot to start with in an area that's highly critical, the HRSG, but where thermal inspection would have the way ANYmal is doing it would have required an operator to go there on a maybe bi-weekly cadence with a thermal gun and check for thermal measurements. But even that would have required a high accurate way of measuring by the human to always go in the same spot and measure the same way, which is something that I think let's leave machines to do and let the human do the thinking and the actions. Once the data has been collected, it is processed by GE's autonomous inspection. And that will collaborate strongly with the Mazin's and Neha's team, where autonomous inspection is one of the modules, part of the essentials, that is taking the image and different data collected by ANYmal, uploaded to the cloud, being processed using machine learning models, right? And then that data will then get fed into the APM software solution stack. Today, with these essentials, you already have autonomous inspection. You already have many use cases that are available beyond what is already available on the robot. You have highly accurate gauge reading. You have thermal profiling, comparing different thermal areas to compare over time, but also within the asset, different temperatures. You can detect change, like corrosion, for example, and you can also quantify corrosion over time, panel monitoring, and the list is much longer. I'm happy to discuss with you the list of use cases. I didn't want to put here an Excel file. I just wanted to share with you just a snapshot of what the solution is offering. Again, as I mentioned, the solution is part of the essentials stack, and that's your bridge, that's your entrance towards the APM software solution. So again, it's all about value. We are not here for fun only. It's very fun, but it's also about generating value and making sure that the plants are working reliably, that we are solving the problems of today, but also of tomorrow together. And our calculations, our experience with GE, and our projections, let's take the 500 megawatt plant case study that Adrian mentioned before, is already showing very promising value that will only increase over time as solution matures and becomes more and more sophisticated, thanks to the collaboration joint development with GE. From reducing risk in probability of catastrophic failure to savings, for example, in maintenance costs, but also, for example, reducing people exposure to hazardous environments. Very noisy pump rooms, ATEX areas, radioactive areas, or simply areas where you know that people have often accidents or are using often their phone, which means you have phone coverage. In another deployment with GE, we have been able to move 2 weeks worth of data processing to 30 minutes thanks to the joint solution. So, of course, how do you start the journey? I think Luke before mentioned all the beta programs. There is an early adopter program that you're launching with GE for this year for companies who want to try the solution over 2, 3, 4 months. The joint solution right on one of their sites. Please scan the QR code. It's also available on the Solution Studio. Come visit us, meet us, we will talk more about it. But basically, you will get a series of workshops. We're going to understand your needs, understand how we can generate value based on your specific configurations of your plant, of your challenges, and from there on, tailor a first pilot program. Then hopefully, you will be convinced to roll it out to your fleet of assets. I would like to thank a lot the GE Vernova team. We really appreciate the partnership. I've been working with the GE team for over now almost 4 years.
Yeah, almost 4 years.
Really, really great company to collaborate with. Very strong partnership and friendly people. And also the customers have been very nice with us. So thank you very much. I'm looking forward to meeting you at the Solution Studio this afternoon. Thanks a lot. Very good.